get started. My name is Jing Liu. I'm the Executive Director of the Michigan Institute for Data and AI in Society, or MIDAS. We're hosting this seminar series and with the support of the School for Environment and Sustainability, which is this building. And so before I introduce today's speaker, I'll just say a few things. What is MIDAS? This is kind of the party line, so I'll get over this very, very quickly. This is a campus-wide organization to enable the development of AI and data science methods and its application across research fields. And so so these days our focus really is very much on AI, as you can imagine. What we do is really we support research. We not just AI and data science adoption, but also the responsible adoption. We train postdoctoral researchers, we train faculty members, and we train staff scientists. And we also collaborate widely with other universities, with industry, and with government. And so this lecture series has been going on for a bit more than a year now. And this is our only seminar series, or only actually event that's focused on the public. So we want to provide a forum for community members to hear the perspectives and also research from our faculty members, and also have the opportunity to talk with experts on AI and data science. No technical background needed. But this is really a very important seminar series in our mind, because really this is I would say this is such a critical time, not just for universities, for scientists, but really for the entire society, how we figure out what to do with AI. And so the next few lectures in this series are coming in February, March, and April. And I would love to see many of you again in these lectures. Also, March 30 and 31st, we're having our annual AI in Research Symposium. And I would love to have you check out our programs and see if this is anything interesting to you. I want to highlight a few things. First of all is we have three keynote speakers representing very different types of research. We have a physicist at University of Michigan who develops AI models for physics, chemistry, and material science research. We have a biomedical researcher who uses AI in his research, and one of his team's research breakthroughs was actually named Discovery of the Year in 2024 by Forbes magazine. And also we have a musician and a composer who will talk about how she and her team uses AI in their creative work. We also will have a lot of University of Michigan researchers to give presentations about their research. We call these AI journeys, and these are about how they decided to use AI in their research, and what kind of challenges they faced, how they addressed those challenges, and what kind of outcomes they achieved. And so for anyone who is at U of M, our generative AI tutorial series this semester have 2 more sessions. So you can check these out too. Okay, yes. Housekeeping items. Bathrooms are outside this door, across the hall, over on the other side. Okay, in the event of fire or evacuation, exit through the doors on this door. Okay, proceed to the external doors and outside the building. Okay, then at the end of the lecture, we will have about 30 minutes for question and answer. Wait for a staff member to pass the microphone to you. And please keep your question concise. And we've definitely had people who basically use that opportunity to make their own statements and so forth. If it's long, wait maybe at the end of after the question and answer session. So just so that we can accommodate as many questions as possible. Okay, and today's speaker is Professor Sophia Brueckner, who is an associate professor at the Stamp School of Art and Design, and also director of the Center for Ethics, Society, and Computing. So I got to know Sophia actually a few years ago when we worked together on a project that used AI to examine the entire art collection at the University of Michigan Museum of Art to see whether AI was able to recognize human figures expressed in various types of art form, but also to see whether the art collection reflected the human diversity in this country. So one thing that I was really impressed with when I worked with Sophia was she literally worked on everything. So she is an artist. She's a designer. She's also a very serious computer scientist. She used to be a software engineer at Google. And so because of this background, this kind of background not only enables her to help expand the imagination of both artists and scientists, but also positions her very well to actually carry out research on how science and technology can empower or hinder humans, and how humans should decide how science and technology should benefit them. And because of this, Sophia is such a great person to kick off our seminar series this semester. So let's welcome Sophia.
I think this microphone is working now. So you can, is that one off?
Yeah.
Okay. All right. Thank you for that very nice introduction, Jing. So today I'm going to talk about, I need to change the computer. All right. So today I'm going to talk about birds. And you might wonder, why am I going to talk about birds when I'm supposed to be talking about AI? And I promise by the end it's going to make sense. So I'm really surprised by how many people have never heard of bowerbirds before. Show of hands, how many people have ever heard of one? All right, that's not everybody. And even for those of you who have heard of them, I'm going to tell you things you probably didn't know. So they're very incredible. I've been obsessed with them for a really long time, and I've wanted to do this project for a long time. By the way, I have a bunch of projects about AI, but I'm only going to talk about one today, which is the bird project. So first I'm going to talk about bowerbirds for a bit, and then I'll tell you what they have to do with generative AI, optimization, and art. Okay, so bowerbirds live in Australia and Papua New Guinea. And there are 20 species of them. Most, but not all of the birds build a structure that's called a bower, and you can see examples of these here. I want to emphasize that bowers are not nests. So these are not structures that are used for raising young. They are built by the male birds to attract a female mate. And there are two main kinds of bowers. There are avenue bowers and maypole bowers. On the bottom here, you can see the avenue bowers, which look like it's like an avenue with two walls, and then maypole bowers are like hut-like structures that are built around a single tree or sapling. I'm going to get into a lot more detail about bowerbirds and their bowers later, but here's just a couple of examples to see of the type of things that they create. So this is an avenue bower created by a satin bowerbird, and the female birds fly into these bowers to view the arrangements of colorful objects that are surrounding them. Then the male bird sings, and there's also like a sultry dance where the male birds show off their collections of beautiful, colorful objects. So it's this multi-sensory experience. This is a maypole bower created by a Vogelkop bowerbird, and the area around the bower structure is called a court, and most of the bowerbirds fill this area with surprisingly complex compositions of colorful objects. And this is why bowerbirds are sometimes described as the most artistic of all animals. And the differences in their aesthetic choices across bird populations are actually why some people say that bowerbirds actually exhibit culture. So these bowerbird displays are really like a multi-sensory experience, kind of like going to an opera. And what interests me the most about what they do is there is no simple explanation for their creations. So first, Before I talk more about bowerbirds, we should watch David Attenborough talking about them because he's the best. So let me show you that. Here we go. And I hope we aren't forced to watch an advertisement, but let's hope for the best.
So that is how it should be done.
So the male bird is the black one, that's a satin bowerbird, and the green one is the female.
Junior returns to his own bower and tries to improve things.
Oh, and actually the young male bowerbirds look like female birds, so it's a little confusing.
That should probably go just here.
So this is a young male bird, but I love it because it's like how artists work, is they like put something down and then they back away and then they look at it and they're like, no, it's not right. I'm going to pick it up. I'm going to move it. I'm going to put it over here.
Perhaps he was right in the first place. He just can't make up his mind. This could take some time. And it's not just about building. The master's bower has something that Junior's lacks completely. Blue decorations really please a female. And the master has gone to town. Junior takes a closer look. What will the master make of his visitor? Rather than drive him away, the master has other intentions. Seduction.
Yeah, so now comes the singing and the dancing. And then they show off their objects.
Juvenile males are almost identical to females. So the master grabs the opportunity to practice his courtship display on him. Junior doesn't know what to do next. So he exits mid-performance.
Okay.
The youngster's bower.
I think that's enough of this video. I mean, you should watch the whole video, but it's pretty great. So anyway, when I watch these videos of these birds working, they really look like artists to me doing work. Like they have like an aesthetic. They're trying things out and seeing if they like it or not. So now Jing mentioned that before I became an art professor, I was a software engineer for Google. And so I wanted to talk about this legend of the 41 shades of blue that emerged around the time I worked there and how it relates to birds. So around 2004 and 2005, Google had this problem that they launched. It was a pretty young company. They launched all these websites and they all had a different designer. So actually every Google product had a slightly different shade of blue. And this was a problem because they looked inconsistent. And in order to create consistency, they wanted to use the same colors, but it was contentious because each team thought their shade of blue was the best one. It might not surprise you that Google did not approach this problem like a designer, but instead like a applied mathematician or a computer scientist. So Marissa Meyer was in charge of this at the time, and she decided, why don't we just take 1% of users and test out all the shades of blue and see which one results in people clicking on links the most. This is what is called A/B testing. So like that is what they did. So Google tested 41 shades of blue to find the optimal blue, and the legend goes that this made Google an extra $200 million. And this story is still mentioned by news articles and UX researchers today. Now, I've never been like a typical computer scientist because I have this artistic side, and despite like having studied algorithms and optimization for a large part of my education, the idea of designing something by optimizing simplistic metrics makes me recoil. I thought this was horrible. Like any other artist knows that colors interact with other colors. Our perception of them changes based on what else is on the screen, the content, and even a user's surroundings or their cultural background. So like the kind of experiment that Google did was useful, but you cannot optimize your way to great design. I tried to use my mathiness to discourage this by asking my colleagues, but don't you know that you just might get stuck at a local maxima? And then they were like, oh, then they got scared because like local maxima are very scary for optimization focused people. So then they would concede maybe we should get a designer involved. I'm sorry, that was my math joke. Not everybody in the room is a mathematician. But anyway, great art and design is not this simple. Great art and design can't come from optimizing single or even multiple simplistic metrics. So applying ideas of optimization and running experiments and surveys on art and design was not invented by the Bay Area as much as they might think they did. Artists have been doing this for a long time, and I'm only going to mention a couple. So this is in the early 90s, Carl Sims explored the idea of how genetic algorithms could evolve beauty. He created a row of screens that had a series of images. There were sensors on the floor in front of each screen, and whichever screen people stood in front of the longest was selected. That image was selected to seed the next generation of images populating the screens. The idea was over time, these images would evolve to be ever more beautiful. And so this project is really relevant when we're thinking about bowerbirds and how their sense of aesthetics evolved. Komar and Melamed are an artist team who set out to understand what beauty is to different cultures. So they actually set up a survey to try to understand what was beautiful in each country. So this is what their survey looked like. So they asked people what their favorite color was, their second favorite color, modern or traditional art, older or newer objects in your home, wild animals or domestic, outdoor or indoor scenes, and so on. And then they got a Chinese painting factory to actually create the most wanted and least wanted paintings for every country. So these are the most and least wanted paintings for the USA. So the most popular painting in the USA is a dishwasher-sized painting with some historical figures, animals, and a lake. And the USA's least wanted painting is a paper-sized abstract painting. France, landscape, historical figure, animals, water. Least wanted, abstract. Almost every country was the same, actually, except for Holland. Their most wanted painting was a magazine-sized abstract, and their least wanted was a wall-sized interior landscape. But this is a really interesting artwork to think about when we're considering bowerbirds, because people think bowerbirds are an example of animals exhibiting culture. Okay, so keep these ideas about evolution of beauty and culture in your mind as we get more into the birds. I can't tell you everything about these birds in a single talk, but I'll just tell you about a few of the species that I think are the most relevant. And I think today, more than anything, I'm like a curator, because I went through tens of thousands of bowerbird images to curate for you what I think is the best collection of bowerbird artworks. All right, so I'm going to start with satin bowerbirds. These are the most well-known because bowerbirds are usually known for liking blue, and that's these ones. So they love blue. They like blue pen caps, bottle tops, blue feathers, blue clothespins, blue ribbons, and I've even watched videos of these birds stealing blue drinking straws out of people's cups at picnics. I'm going to go kind of fast because I have too much bowerbird content. Bowerbirds improve their bower building and object arranging skills over time. So the bowers of older birds are built more neatly and their arrangements are more sophisticated, which the female birds appreciate. And male bowerbirds also seem to learn from each other, sabotage each other's bowers, and steal each other's objects. And actually, like, their bower building skills take years to develop. Like, it's not just a few months, it's like years, which is really significant. Sorry, I'm going too fast. Birds. So you can see there's like variation. So I've been showing you a lot of images from the Cornell's Macaulay Library, and they have like lots of images, user-uploaded images of birds, and they have a star rating system. And so this is an example of the failure of simplistic metrics, because what I think is an interesting, as an artist can think is an interesting bird image, is usually rated 1 to 2 stars. based on quality, which isn't defined. Like, for example, I love this image of this bower with a single blue scrunchie. I think it's just amazing, but it only received a single star. And most of the images I'm showing were rated less than 3 out of 5 stars, so I actually had to like go through a lot to find them. And so what does it even mean to have a high quality bowerbird image? It seems like people think it's just like the sharpness of the image and not the composition. So there's not really a simple metric for it. So to attract a female, there's a dance where they show off their objects. And they really favor blue, but they also use yellow leaves and flowers. And I've noticed that when they do their sultry dances for the ladies, they often hold one yellow object and one blue object in their beak at the same time. And this is something I noticed as an artist. And as far as I can tell in all the literature and talking to ornithologists, like they just didn't notice that they're doing blue and yellow at the same time. And I'm like, that's obvious. Those are 2 complementary colors. Like they have a different number of rods and cones in their eyes, so I don't know how they see yellow and blue. But to us, that creates a vibration, and it's a very scintillating effect. So, but like an artist sees that, but scientists don't always see it. Anyway, but look at all these images where they're holding blue and yellow at the same time. I think that's pretty incredible. Okay. Vogelkopf bowerbirds have the most complex bower situations, and they use a lot of color. So we can watch a video of one of them because they're they're really amazing. And let's hear. Okay.
Bowerbird.
We'll just watch a little bit of it.
He might lack the plumage, but he's got an extraordinary repertoire of song. And he's a wonderful mimic. Those are pigeon wing beats. That's a modest tiger parrot.
Just want to skip to
For color.
the colors.
This male favors red and orange flowers.
So like these things decompose, they have to constantly replenish these things.
And
these
he's very
piles.
fond of fungus. Not everything he collects stays where it should. He puts these treasures on display within and around a construction that has taken him years to build. A giant bower woven around a central sapling, carpeted with moss. This grand design is no nest, it's the ultimate seduction parlor. But he's not alone on this hillside. He's got 6 rivals within earshot.
Okay, that's enough of this one.
Prefers darker colors,
that looks pretty
decorating his
amazing.
bower with deer dung.
Yeah, even birds near each
And
other are
charcoal.
favoring different objects. I think it's just so fascinating.
Visual effect is of crucial importance. Clearly, he hadn't planned on all this sprouting fungus.
He doesn't like it. It did not turn out as he planned.
He and his nearest rival live a
Anyway,
stone's
so
throw
like
apart.
they're little artists. Okay. For the sake, I would watch it all, but for the sake of time, I'm going to go back to my slides. There'll be more. So they often use blue, but they'll use pops of orange and red. And they do make piles, but they often will place single objects. And that is what really is interesting, because you can't describe what they do as just getting the most of something. They're clearly creating a visual composition with the objects. So if you look at these, it really looks like they're creating compositions. Like there's like one can. And he's being very particular about where it goes. All bowerbirds are extremely particular about their compositions, and if someone moves their objects around, the bowerbirds will move the objects back to where they were. So like they've tested that. When foreign objects, like when someone puts different objects in there when they're not around, the birds will take them out. So they have a very specific composition in mind. Look at that, that's amazing. Look at that single orange leaf, that's amazing. This one is amazing, look at this. Like this one too is one of my favorites. Also, they've tested with the birds that if scientists have like left different colored objects out and let them choose, and each bird, like different birds have different preferences for different colors. This image kind of gives you a sense of how big these things are. So I just put them all in here. I couldn't edit down. And so the fact that different species, different birds of the same species might favor different colors and types of objects is why some of them, some people think they exhibit culture. So with the bowerbirds, there's this question of why they're doing this. And so how is making these arrangements showing the female birds that they are better mates? Does it show them that they have better genes somehow, and why? It doesn't, does it show them that they're stronger or healthier in some way? And why isn't it just the bird with the most stuff wins? Because that would be the Bay Area mindset, that if you have the most, or you're the fastest, or it's the most optimal, that would be the survival of the fittest. So that's what it should be. But here's an example of something that evolved clearly differently. Does the rarity of the items show that the birds are superior in some way? And that also science has studied that, and it's not true. Bowerbirds use whatever's there. Great bowerbirds use less color, but they have discovered some interesting things about what they do. One paper I found said they arrange objects to create an optical illusion using forced perspective. So this is what they do. So this is an example of forced perspective in a human artwork. So there's an illusion that everything's at the same depth. And they've discovered that these birds do something similar. So they use a gradient of gray, white, and green objects to create an illusion that all the stones are at the same depth. And you might ask yourself, if you were thinking of like a Bay Area engineer, is this making the birds look bigger to the female birds, or like bigger or stronger to the female birds? And actually it's the opposite, it makes them look smaller. So that also doesn't account for why they're doing this. Spotted bowerbirds, they do white and silver and green too. I'll just go through these pretty quickly. They also collect bones and shells, which is really amazing. This is one of my favorite bowerbird artworks of all time. Look at this, there's zip ties and Christmas ornaments and marbles and shells. And then there are other bowerbirds. So I'll just fly through these so you can just see the range, but each species of bowerbird does really different things. One works with this lichen and creates these pale green compositions. Some of them actually use berries to paint the inside of their bower red, so they're actually painters. It's often red, not always. Some of them use green leaves. That's a different species of bowerbird. And all of these have to replenish these and maintain their compositions over time, which is a lot of work. It's definitely not efficient. Okay, so there's a lot of controversy about bowerbirds, and this controversy is one of the reasons I find them really interesting. The way that they evolved and are so varied and seem to defy these simple metrics like strongest, fastest, and most. And this interested me because I'm I was in the Bay Area, I'm a computer scientist, and I'm an applied mathematician. Everything is about minimization and maximization problems, and you just can't do that with these birds. And this simplistic idea of survival of the fittest just doesn't make sense with what these birds do. So this book came out in 2017, and its rebuttal was here. But other than that, for one example of the forced perspective illusion, which is like one paper, what these birds are doing is so difficult to put into words. And as a computer scientist, I would really struggle to write an algorithm or code that is doing what these birds do. And that is why I'm so obsessed with them. Like I can't describe what they do as metrics or or as a series of discrete steps. And so this leads me to my next point. I think it parallels this generative AI human creativity controversy. People in the tech world usually can't explain what artists do. And actually the reason why, the fact that scientists can't explain what Bowerbirds do is why they call it art. Because they can't explain it, so it must be art. It's hard for most people to explain what artists are thinking or what makes it good. And so this is frustrating to computer scientists, because what are your metrics for success? And this whole controversy has emerged with generative AI and art making, and it's so similar to the controversy around what Bowerbirds and whether they make art or not. Do Bowerbirds make art? Does generative AI make art? And what is it? What makes it good or not? So you've probably seen these headlines where AI companies have scraped people's artwork without their consent and used it to train AIs that can make, quote, art. Some of these things have actually fooled people and to win art contests, which makes a lot of people mad, and some people are delighted. People are wondering if these things are going to learn and improve, and they will eventually evolve into artists making great art. And here's a quote from this article. "This isn't going to stop. Art is dead, dude. It's over. AI won, humans lost." This is the guy who made this image and won this contest. And so 20 years later, it feels like we're back at the 41 Shades of Blue again. Like we're trying to optimize the best art, or Google was trying to optimize the best design. Only I don't think my local maxima thing is going to work this time. So I'm an artist, so I'm struggling with these questions, and I'm thinking about it a lot. And the way I think about things is through making. So I am building. This is a project that is in progress. I am currently building a robotic Bowerbird to explore all these ideas and investigate these questions about human creativity. So people have made a robotic Bowerbird before, but this is a female Bowerbird. So no one has ever made a male robotic Bowerbird, and this one was actually meant to study their behavior. So this was done by scientists. My current plan is to work with a robot arm, or my ideal plan, robot arm is easier, is to have a suspended robot that is on cables and can move around and pick objects and put them down. This is like a mock-up for what I want my plan. So the Bowerbot is a robotic Bowerbird that will transform an empty gallery space by arranging colorful objects such as flowers, leaves, and trash. And visitors will come in, offer the robot objects, which it might accept or reject. So it'll decide if it likes your object or not. And then it will use artificial intelligence trained on photographs of Bowerbirds' elaborate bowers. It will learn how male Bowerbirds create artworks to attract a mate, and then it will place those colorful objects into compositions. One of the things I also dream of doing is to have a series of images on the wall where they're actual Bowerbird artworks taken from the point of view of the female bird. One of the biggest frustrations is there are no images taken from the right point of view. They're all taken from the outside of the bower. They're never taken from the actual point of the view that the female bird is perceiving the composition. So this is a real limitation of the data. So I would love to have a series of those and then scale them up to human scale so we can actually get a sense of what this is happening. Just doing that, I think, would be huge. And so what I'm trying to do is use this project to uncover and exemplify the problematic assumptions about algorithmic reducibility of creative processes. So I am skeptical that we can reduce creative processes into algorithms. And I love algorithms. So conversations about artificial intelligence are derailed by people's predisposition to anthropomorphize AI. We're always talking about AI as if it's somehow simulating human intelligence. It's really frustrating to me, and this is something tech companies encourage because they want you to trust it. And that's why they want us to think that it can replace human creativity. But the way generative AI, like things like ChatGPT and Midjourney, produce output is nothing like how humans create at all. And as these things proliferate, I think it's urgent that we have a better understanding and more nuanced conversations about creativity and AI. And this is my way to talk about it. So for those of you who are AI people in this room, I have tested the Bowerbird images with image segmentation algorithms, which is a type of AI. It actually works pretty well. And also with depth detection algorithms, and it actually works pretty well. So my current theory for how I'm going to do this is to segment the images and find the blocks of color. Then to use depth detection and figure out where these blobs of color are in space. And then project those onto the horizontal plane, and then use those projections to train new compositions, and then use that to make my robot. So this is my current hypothesis, and anybody in the room who has better ideas should come talk to me after. But I won't get too much into the technical details, but that's currently my theory. So challenges. I told you there's a lot of challenges with this problem. So the first of all, there's not enough, there are a lot of Bowerbird images, but you really need a lot of images to train AI, a lot more than I can actually get. So I could scrape the whole internet for every Bowerbird image that exists, but it's still not like as much as you would normally use to train an AI. And then there's the other problem that they're all taken at different points of view. And the only ones that I've ever seen that were taken from the point of view of the bird, the female bird, the way the composition was meant to be seen, were these two images in one paper. So like that's 2 out of like all of them. The other problem is, my human eyes are different than Bowerbird eyes. They have a different number of rods and cones. They have eyes on the side of their head. They just perceive these things differently. So like that's going to always be a problem. And this is just interesting. I looked at historical illustrations of Bowerbirds, and to me, the compositions and the illustrations are not nearly as interesting as what the birds actually do. So I think this is just like a limitation of the way humans assume these birds work. So, so this is all in progress, and I wanted to have more done during the year, but I always think I'm going to get more done during the school year than I do. I'm so much more ambitious, and realistically, everything I do is over the summer when I'm not teaching, but these are the questions I want to address with this project. So are Bowerbirds artists? Can generative AI be an artist? When a human artist creates, an AI artist, who's the artist? The person who made the AI artist or the AI artist? And how does this all fit into our ideas of creativity and beauty? Can we learn anything from this? What is culture? Do Bowerbirds exhibit culture? And can generative AI have culture? I think that's a really interesting question. So the tech world is really preoccupied with optimization and efficiency, which I hate. I question that as being efficient as being good. What is optimal if there are no clear objectives like strongest, biggest, and most? This challenges the mainstream understanding of evolution and the survival of the fittest. There are no clear objectives with art. A Bowerbird composition fails when the male bird does not attract a mate. When we're talking about generative AI and human creativity and art, is the only metric for success if humans get fooled? I don't really think that's very interesting. Should we be treating art, design, and beauty as an optimization problem at all? And so by focusing on Bowerbirds, I think this is one of the most important things. By focusing on Bowerbirds and creativity, I am circumventing this trap of human-centric thinking to put AI in a category of non-human creativity, which is where it belongs. It does not belong in the conversation with human creativity. It doesn't think like a human at all. And I will train an AI on Bowerbird art using the same processes that tech companies use to train generative AI to produce human-like art. But rather than fixating on how AI is a competitor to human creativity, I'm going to redirect the discussion so we can have a better conversation about AI and non-human creativity. And so other questions, like what is non-human creativity? Is it more about the process or the output? And if AI actually is creative in some way, can it be useful in its own expressive form? Like AI is a black box. You cannot really understand why it made decisions like a human can. Like I can explain how I made decisions, you can't get that from an AI algorithm. So if Gen AI is thinking, if you want to call it thinking, it's not thinking like a human, and it never will. So what can we even learn by watching it make decisions and watching it in action? And so this sense of not knowing reminds me of another artwork by Sophie Brueckner, which is one of my favorites. It's called Take Care of Yourself. In 2007, a boyfriend broke up with her over email, and this made no sense to her. So she asked 107 women from the realms of anthropology, criminology, philosophy, psychiatry, theater, opera, soap opera, and beyond to each take this letter and analyze it. And then she took all the results and exhibited them. So she thoroughly analyzed this problem But I don't think it makes the breakup letter make any more sense. So like I think there's a possibility that doing this whole thing is not going to answer these questions, but it's worth it in itself to even do it because of the conversation that results. And so maybe the Bowerbot will similarly celebrate not fully being able to make sense of human creativity. And will we ever be able to understand why Bowerbirds do what they do? And will we ever be able to clearly explain what artists are doing what they do? I have some opinions about that. We can talk about that in the Q&A. So anyway, the tech world is claiming that AI can replace human creativity, which is making some people excited, a lot of people really mad, and some people greedy because they're going to make money. And I'm going to try to use the same technologies as these companies to simulate what Bowerbirds do. And so I hope this is going to help people have a better conversation about it. And yeah, I made this graph, which is kind of funny because it's like what computer scientists are doing to human artists, I'm kind of doing to the birds, which makes me feel a little bad, but I'm going to do it. Anyway, so by building an AI bird artist will allow people to consider the loaded topic of AI simulating human creativity from a distance. And it's going to help us think about AI and its creative capacities and uses. And most importantly, I wanted to warn us about the dangers of anthropomorphizing AI so that we can talk about it as a non-human intelligence. So I have funding for this project. I still have a lot of work to do. I'm collaborating with MIT's Center for Bits and Atoms on it, and I'm looking for collaborators here in Michigan. So I'd love to talk to people about the project and all the many challenges I have. And if anybody has any great students that have skills, related skills, you should send them my way. And I'm happy to answer any questions about AI or birds. And I think you are supposed to use the microphone. Oh, you have a microphone.
Yes, if you have a question, just put your hand up and one of us will bring a microphone to you.
So, I mean, you were sort of getting at this at the end, but I'm curious, I guess, for more of your thoughts about, you drew this parallel of and you talked about how generative AI should not be considered the same as human creativity, is not the same as human creativity, and these are different realms. And so, you through this project are exploring drawing this analogy and connection between, you could say, I don't know, bird creativity or whatever you want to call what Bowerbirds are doing, right? And generative AI. And, there's this sort of parallel of anthropomorphizing generative AI, and I don't know what you want to call it, ornithopomorphizing generative AI, right? But I don't know, I'm curious for your reflections on on that as an aspect of this project and how you feel about these are still biological beings with sentience that have some flavor of creativity that's different from human thought, but is still not being captured by generative AI because it's a different kind of thing, right? Yeah, I'm just curious for your reflection.
Yeah, I mean, I'm still figuring all this out, but I've thought about how AI works, and it's it looks at a whole bunch of, stuff, and then based on that stuff, it produces the most probable result to a prompt. And I thought about it, when I go into my studio, I'm I have a question, but I'm not what is the most probable painting I could do in reaction to this question? That's just not what artists do. That's boring. And so I just don't, I think that's already a limitation. And actually the fact that I can't put what Bowerbirds do into steps and the only solution I have is to use AI kind of I think exposes the problem also, because I can't it's the only way I could even try to simulate what they do is by using this sort of an AI system. So I don't know, that's the tension I'm playing with, and I hope I actually think by making it I'm going to have a better answer to that question. Yeah.
Thanks so much for this presentation. It was really cool. In your plan for the project, you envisioned this robot arm. I wonder if you were considering at all just having AI kind of generate a floor plan for you that you then went and placed, or is there something important to you about the AI controlling kind of the the physicality of the assembly?
That's an interesting question.
Yeah.
I'm willing to be a bird. I would do it, but in my mind, I kind of love the idea of a robot taking a blank white gallery space and transforming it. Like that's what I find that very poetic, that it's like making the exhibition autonomously. So I like that a lot. And I like the idea of like offering things to a robot that it rejects. But yeah, I mean, I have a feeling that I might have to be, in the early stage of the projects, I might have to be the bird. That's a good idea, actually. Because like getting the robot to work is a whole problem on its own.
Two questions. I'll put out one, maybe come back to the other. Technical, you've mentioned what sounds like transformer architectures. Have you looked into diffusion models, which is shown much more promise for creating new things from existing?
You're asking about diffusion models?
Yeah, in the flavor like David Baker's work and proteins and stuff like that, which won the Nobel Prize. So
I haven't decided how I'm going to generate the new compositions. I might use them.
Okay.
Yeah, right now I'm more worried about like looking at the existing images and making sense of them. Like that's the stage of the project I'm in.
Okay. The second is about birds.
Yeah, okay.
You talk about culture, but I assume there's some research out there that would indicate whether what one bird is doing gets passed on to its neighbors somehow.
They have found that.
Okay,
yeah,
so there is some indication that it's...
Yeah, they found like populations of birds of the same species that don't overlap. They have different aesthetics, and then when they do sort of mix, they sort of learn from each other, which is pretty amazing.
And any genetic components? I mean, does one bird inherit something from its parents?
I don't know about the genetic. I don't know if I've seen anything about the genetic component. Yeah.
Hello. Yeah, thank you so much for that incredible research you're doing. I was just interested in what some of the Bowerbird researchers are obsessed with wanting to work with you might be about. Are there any key questions that they're excited about? Do you think that you've met people who are working with Bowerbirds? They'd be like, there's a mystery, we need to uncover it. How can you help us?
Have they asked me?
Yeah, are they desperate to uncover?
No, they're not desperate. They all have their own obsessions. Like the researcher I talked to the most is the woman who made the female Bowerbird robot. And so her obsession is to understand how the dancing communicates. So like I learned a lot from her, but she's like super focused on just like what do the motions mean. And so like that was the whole point of making the robot, was to like have the robot test things and then try to determine what those actual motions mean to the birds themselves. I think probably if I could get to Australia or Papua New Guinea, I would love to talk to more of these researchers in person. Like I want to go visit the people who study these in person so badly, and I want to build like a Bowerbird selfie stick so I could go take pictures at the right angle. Like it just makes me crazy that all these pictures are not at the right angle.
Hello. On a similar topic to that, have you thought about engaging a citizen science aspect in Australia to try to capture some of those images? Or?
I have tried cold emailing Cornell to see if I could get them, but I haven't tried Australia. Mm-hmm. I mean, it's hard to know exactly what the scene is in Australia. I've never been, what is their citizen science scene like? I know the US scene pretty well. Mm-hmm. But yeah, that's a good idea. Maybe they can make a bunch of selfie sticks.
Why not?
And go take pictures at the right angle. That would help me a lot.
I volunteer.
You do?
Yeah, there are definitely guides there that take people
to look at the birds.
Them. Yes. Yeah. I'm gonna introduce myself to you after, but I thought it was super. I started getting excited about your project, and my husband teaches here at the U and is fascinated by AI as well. And he has been talking with me. I'm a graphic designer, by the way, and nothing to do with academia. But he has been talking to me about how generative AI is, I don't really understand it, but I'm sure you do, computers training each other. Like that's where that's where a lot of the impact comes from, is when they're actually, one of them is playing with the other one, and then all this stuff comes out of that, like two computers working with each other. And so, of course, when you're talking about the Bowerbirds in proximity to each other and how they learn from each other, I'm wondering, your project seems like it has so much potential as time goes on, because your robot, you might have two robots, and they might start to learn from each other, and you were talking about how the Bowers get better and better as the birds get older. So you kind of wonder what's going to come out of this.
I would love to have multiple and learn from each other, but there's actually like multiple AI problems in the one project. Like just getting one working is so hard.
Sure, no, but it's just exciting because it seems like it has tons of potential, and also, you know, the whole question of how it relates to art is so fascinating. So anyway, I love it.
Oh, thank you so much.
Yeah, thank you.
Hi. So my question is, do you have any idea of what your AI will reject? Cause I'm curious if you want to know, like, cause like AI is like taught by like what it's fed, right? So do you think that the AI is gonna learn and then like learn to reject stuff based on like what other birds reject?
That's a possibility. I've thought about multiple ways to do it. One might be, like, if it has an ideal if the robot has an ideal composition in mind, does the given object fit the composition? And if it doesn't, then it rejects it. If it does, it accepts it. Like, that's one algorithm, but that doesn't that wouldn't create learning over time. The learning over time would probably be an additional feature that I'd have to think about more. And maybe then I would, because like a lot of these algorithms do actually do a pretty good job of segmenting the piles into individual objects and actually classifies them okay. I've tried classification on them. So I could like train the robot to, like, I could train the robot on images of like what objects bowerbirds tend to like. But I don't know if it's like my first priority, but it's like there's multiple ways I could do it, and that's a really interesting question.
Okay. Yeah. Thank you.
Hi, thank you for the presentation. So I'm just curious about if you're gonna build a like bot for the Bowerbirds, would that, like, the environment have an impact on like how the bot would like produce their decisions? Because so when I saw like the YouTube video about like how they build things, so like some things would not like be at the same place the Bowerbirds want them to be because of like the environment is not very flat because it's in the forest. But like if the robot would be like building a bower inside of like a like maybe an exhibition, the place would be like really flat and maybe like just a simple white color background. Would like the background color and how like the maybe it's like whether it's flat or not flat have an influence on the robot's decision?
I think I'm going to stick with simplicity because it's already so hard, but I think the birds probably do pay attention to the contrast of the objects placed on the background, because like I'm thinking about especially those birds that were placing those like mint green types of like foliage and lichen on top of a dark background like that. I think I feel like the birds have a sensitivity to contrast, and they have a sensitivity to color combinations. And so I think that it matters for the birds, but for the complexity of my problem, I'm not going to be able to do everything.
Thank you.
One more question.
Hi, I'm a little more interested in, or like the data that you're trying to pull from the images to create like the AI for the robot, and what you're trying to get from the different images.
I am trying to determine where the blobs of color are, and then where they are in space. And the problem is that I usually only have one image of a bower. It would be easier if I had multiple, but usually there's only one. But the depth detection algorithm seems to be doing pretty well. So the thing I'm going to be trying right now, like over the next month, is to see if I can create like a point cloud of colors, and if I can use that to generate anything useful to me at all. I'm hoping, but that's what I've been, that's what I'm going to try to do.
I'm not sure. I'm not too sure about it, but I've been hearing about things like where you can photo scan from images, or like transform the images into 3D models. Have you tried something like that?
That's pretty similar to I'm pointing at the slides, but it's not on the slide. But it takes it does the same thing. It takes that depth map and then it tries to turn that into a 3D image.
Mm-hmm.
So those work. I don't know how well it would work on a Bower. I have seen those, but I was going to just hope for points and see if I could work with that. Because like having something that actually is like a closed object seems like that's not going to happen. So maybe just dealing with points would be enough. It's probably enough for what I'm doing, I think.
Yeah.
Yeah.
Any other questions?
Okay, so let's give another round of applause for Sophia.
Thank you so much.